Hi students, this is Unit 2, Lesson 2, 3 parts of the brain and the cerebral cortex. Please stay tuned for lots of different videos which will demonstrate to you the parts of the brain and more specifically the structures and functions of various parts of the brain and central nervous system, and identify methods and tools that we have used to study the nervous system and mainly the brain. What we know about the brain really comes from conjecture. It started many years ago, of course, and one of the theories was phrenology, which has been debunked because phrenology studied skull bumps, and if you had a bump on your skull, that determined whether or not you were going to be like benevolence, there's a word in here, constructive. No, it's not a thing, but it was a way for people to kind of explain why people are criminals and why they're not, based on the bumps on their heads. So early methods of studying the brain were really all just conjecture, like I said, and just people taking guesses. Today we know that the brain is divided into 3 sections, and those include the hindbrain, the midbrain, and the forebrain. And you can think of the hindbrain, or the back of the brain, as the vital functionings of our bodies and what we need to survive. So this is the lower portion of the brain. It is the first to develop in human beings. It's vital functions, heart rate, respiration, and balance. And it includes the medulla, vital functions, the pons, body movement, attention, and sleep, and cerebellum, which coordinates our balance and coordination. So if you are active, if you're one of those kinesthetic learners, you have a cerebellum that is coordinated well. Medulla helps us, like body temperature and homeostasis, maintaining balance within our body. So those are internal functionings that are essential to development, survival actually. The midbrain is involved with vision and hearing, and reticular activating system is one of those processes, which includes attention, sleep, and arousal. So your RAS is essential for things that you're paying attention to. We'll learn more about that when we come to sensation and perception, but the RAS kind of acts like a filter to things that we selectively attend to. So it helps you to be aware of things, well, that you like. In our forebrain, then, the final part is the thalamus, hypothalamus, limbic system, and cerebrum. Now, all of these things we'll learn more and more about, but those are also a little bit more to do with our choices and decision making, but also hunger, sleep, motivation, sex. So hypothalamus regulates those things, and the thalamus is the relay station. So it sends information up to our cerebral cortex to make decisions. The limbic system includes the hippocampus and amygdala, which are motivating areas which include memory, emotion, sex, and aggression. So your hippocampus is integral to long-term memory. Your amygdala is your emotional processing areas. So amygdala is arousal, it's anger and aggression, and then your cerebrum is the outside of the brain, the large part of the brain, 70% of the volume, active in coordination and voluntary activity. So when I kick a ball, it is my cerebrum which extends those messages. Furthermore,
with connections with the new brain, the cortex. Though less than 1/4 inch thick, the cortex is the brain's crowning glory. Among its roles, the cortex is our reality check. It filters and orders the outside world for us and allows us to see, touch, hear, and speak. The cortex is also the human thinking cap. All our plans, thoughts, and ideas.
Your cerebral cortex, as you can see, is the meaty part of the brain. It's where all those neural networks that I discussed in the previous lesson are made. And within your cerebral cortex are different lobes. So your frontal lobe, parietal lobe, occipital lobe, and temporal lobe include the following processes. Your frontal lobe is what makes you you, the creative side, your movement and thinking. Your parietal lobe is where information goes so that we can regulate touch, sensation, and spatial relationships, where things are located on our bodies. Occipital lobe is visual, so you go to the optometrist to get your occipital lobe checked out. and your temporal lobe is next to your ears, include processing sounds and speech. Furthermore, in the cerebral cortex include the motor cortex and the sensory cortex. Now I want to show you some demonstrations on how we know what we know about the motor cortex and the sensory cortex. Motor cortex is motor coordination, movement, and sensory cortex is the internal stimuli I talked about in lesson 1. Sensory information, and then we receive that information and register it. What does it mean to us?
That pencil-like instrument in his hand is an electrode. Each time he applies it to the patient's brain, a weak electric current stimulates that part of the brain. You'll see how it evokes a body movement or a sensation. Ready? On.
They're delivering an electrical impulse to the motor cortex or sensory cortex.
Nothing at all. Ready? On.
The left wrist is beginning to flex, the left elbow is bending, fingers are twitching, the hand is twitching, the arm is shaking. Stop.
Buddy, what happened?
I think his hand moved.
Did you move them?
This I don't quite understand, Bob. Why do you have to remap, rechart each individual brain? Aren't they all alike?
One brain is not exactly like another any more than our faces are exactly alike.
In this video, the man who's getting the electrical impulses onto his brain is conscious and is able to relate the experience to the scientists and let them know what he's thinking and feeling. So this is how we have learned about the cerebral cortex in the mapping of the cerebral cortex. Now, again, the sensory cortex is going to be things like sensation, like, I smell fresh baked cookies when somebody gives me an electrical zap on my sensory cortex. Your sensory cortex is behind your motor cortex when it comes to the information, the mapping of it, and includes, as you can see there again, motor cortex, visual cortex, auditory cortex, and olfactory cortex. Olfaction is your sense of smell. Audition, of course, is hearing, and vision. Now, other places your cerebral cortex again has been mapped out due to experiences include association areas. Association areas are those places that are devoted to speech, language, processing, and one that has been mapped out is called Broca's area, named after the doctor that found it, which is responsible for producing language. It is located in the left hemisphere, and if a person has Broca's aphasia, they may have difficulty understanding language and communicating their own words. Left frontal cortex is where language is, therefore that's where Broca's area is. They do know that they are unable to adequately tell the person they're speaking to what they're trying to. Here's an example.
Now tell me what this thing was with your legs last week or week before.
No good. Ache and knees and ankles.
What'd you do about it?
Home, doctor, and legs. Walking, no good.
No good, huh? And you're a fellow who likes to walk, too.
Oh, jeez.
Huh?
Oh, boy, oh, boy.
And it's getting too cold
Yeah.
to run your John Deere tractor, isn't it?
Yeah.
Up and down town.
Yeah.
What'd the doctor tell you, Jack?
Don't know.
He doesn't.
In that video, then, you can see this man may have suffered from a stroke and he's having difficulty understanding language and being able to find the words to communicate exactly what he's trying to say. So it's an aphasia. It's a deficiency in his speech. Next, we have Wernicke's aphasia, again named after scientists that found it. And you can see that it's in the rear. It's near the sensory cortex. So that makes a difference. Wernicke's aphasia is caused by damage to Wernicke's area, the green section. They find it difficult to understand speech, and then they have unintelligible, maybe nonsense words. I'm going to show you an example of that. They are not in the know, the fact that they are not communicating effectively.
Thanks. Say baseball player, baseball who's pronouncing. Caterpillar, cantaloupe. Okay. All right, I'd like for you to do some things now with your mouth. First thing I'd like for you to do is stick out your tongue. Stick your tongue. Show me how you would kiss. Show me how you love kissing. There you go. Show me how you sip on a straw. Can you sip on a straw? Okay, try this one. Wait a minute. Listen. Show me how you smile.
So you can see that, again, she's unaware of her situation or that she is not effectively communicating. So kind of sad. The cerebral cortex is connected by the corpus callosum. So the red section there in this graphic, this is the structure that connects the two hemispheres of the brain. And allegedly, the left hemisphere controls language, logic, problem solving, and math. Now, I say allegedly because we have people who theorize that you're either right-brained or you're left-brained, and that's not a thing. You are total-brained because, you know, it's not true that 10% of your brain capacity is only used. Your entire brain is being used all the time, yes, but maybe we don't tap into some of our abilities as well as somebody like Einstein. The right hemisphere deals with imagination, feelings, art, and spatial relations. So those things, yes, are true, but we are whole brained rather than either left brained or right brained. You can be left brain dominant, right brain dominant. You're always using your entire brain all the time. Otherwise, you wouldn't be breathing or thinking or doing the things. All right, so there's a brief overview of the brain and the cerebral cortex. We have investigated the structures and functions of various types of parts of the brain and the nervous system and identified tools and methods that we use to study the nervous system. Some of those tools include electrical stimulation to parts of the brain, and people who have been damaged, you know, the men and women that we just saw had brain damage through maybe a stroke. And so we learn more about my brain and your brain because of people who have come before us with unfortunate injuries.